Hello everyone. Today we will study the application of thermal expansion, that is thermal stress. What is the benefit of it and what role it's play? We will see it. When the example of it, when we see the railway lines, we see a gap in between these lines. Also, when we see the bridges, there are left a gap in between these bridges. Why are these gaps here and what are the use of these gaps? We will study it with the help of thermal stress and thermal expansion. So, what is the thermal stress? Thermal stress is the when we take a metallic body or a metallic, we are taking here a metallic rod, and both ends of it are fixed, rigidly fixed, that when we try to expand it, it does not expand, and we are providing it thermal expansion or temperature. So it will try to expand on either side, but due to these two fixed ends, this does not happen. So this rod will try to bend in its shapes. So its shape may change. So this is the thermal stress. Means when the rod is trying to expand, but due to both ends are fixed, it cannot expand, and there is change in the shape of the rod or the metallic body we are taking. So we can write the definition of it here. So thermal stress is a stress which is developed or set up developed when we expand a metallic rod by rigidly fixing its ends. Ends. So this is the thermal stress, and mathematically how we do the calculation of it, we take gamma. This is Young modulus. Why we are taking here Young modulus, not the bulk modulus and shear modulus? Because we are here taking compressive stress and we are taking a long rod, so the strain is also longitudinal strain. So that is why you are using Young modulus, and it is equal to stress upon strain. And what is stress? Stress is force upon area. And what is strain? Which is longitudinal strain. Longitudinal strain, that is change in length by original length. It is equal to Young modulus. So further, we can take change in L, delta L by original length, equals to F upon, we have taken this Young modulus here. A is here area. Now this change in length upon original length. Here we have where we have studied it. We have studied in thermal coefficient of linear expansion, which is equal, this is equal directly proportional to thermal coefficient of linear expansion. So equal to alpha to delta T. This alpha is thermal coefficient of linear expansion, because we are taking a long rod that is that causes linear expansion. Now this all threes are equal, so we are taking both of these. Now force upon area, we are taking Young modulus to this side. So and what is force upon area? That is stress. We can say thermal stress, and it is equal to alpha Young modulus into delta T. So this is our thermal stress. This is the stress which is developed in a long rod, and it is directly proportional to change in temperature, thermal coefficient and Young modulus. And if we want to calculate the force, this will be equal to, force is equal to alpha Young modulus into A into delta T. This will be the force. So now mathematically we have represented how much is the thrust developed between a long rod when its both ends are fixed. That is why there are gaps in between the railway line or the bridge, because due to thermal stress they will expand and their shape will change. So this will not be good for the purpose of transportation. So their shape may change. That is why we leave the gap in between. So when thermal stress occurs, its shapes change. So it can expand here, and this gap can get over. So same is the case with bridge. That is why in huge bridge the gap is left in between, so that when there is expansions, these gaps can be filled, and the shape of this bridge do not change, and there are chances of collapse which can be reduced. So that's all.